everyone, our function is defined over interval 1, 5. Our function is 1 divided by x. We're going to approximate the area by partitioning 1 through 5 into 4 subintervals and into 8 subintervals of equal length, and choosing u as the left endpoint of each subinterval. We're also going to express the area as an integral. I'm also going to evaluate the integral. So I went ahead and did a little graph here. Our endpoints are here, 1, 2, 3, 4, 5 for the first one. Since we have 5 endpoints, they want us to start at the left endpoint. So we're going from 1 to 4. All right, and if you're going to partition it, what they want you to do is, since we're starting at 1, you go up here, then go across to 2, and then go down to this. And then from 2, you're going up here. Then we're going to 3. And then from 4, you're going, so you can count that. And then from 4, you're going up here. Well, 3, you're going up to here, sorry. Going to 4. And then from 4, you go up to here. And it's very close into there. And then we go down. So let me just cover this in. All right. So that's our little rectangles that we're going to be adding up. Now, we have 1 to 5, so we're going from 5 minus 1, and we're doing 4 intervals. So that's going to equal 1. So that means we're going by ones. So to approximate the area, what you do is you take your area, and you take f of 1 times your number of intervals, or your length of your intervals, equal intervals. So that's going to be 1 plus f of 2 times 1 plus f of 3 times 1 plus f of 4 times 1. So here are your 4 intervals that you're going to take, add up the areas. And when you do that, you're going to get, and since we're just multiplying by 1, I'm just going to kind of leave that part out. So you have f of 1 is 1, f of 2 is 1/2, f of 3 is 1/3, and f of 4 is 1/4. And this equals 25 divided by 12. So that's the area, if we, approximate area, if we do the 4 subintervals. Now we're going to do the 8 subintervals. So what I'm going to do is duplicate this page. You're not going to be able to see that I'm doing it, but I'm duplicating it. So I don't have to, I didn't duplicate it, so let me duplicate the page. I'm going to duplicate the page and the ink. There we go. So I have this, and now I'm going to erase it. But you're not going to lose it because I duplicated it. Now we'd have to do 8 intervals. So basically, we're doing 5 minus 1 divided by 8. That's going to equal 1/2. So we have to go by 1/2. So this little piece is going to be 1.5, 2.5, 3.5, and 4.5. We're still starting at 1 as our endpoint. So basically now when you draw this, and I'm going to try to erase some of this, erase as much as I can of this. All right, so when you do it now, we're going the same way. We go up to 1, but then we only go to 1.5. Then 1.5 goes up to here, go down to here, and you go to 2. You draw down. 2, you start here and go here. Then 3 goes from here down. Then 3.5 is going to go from here. Let's see, what did I do wrong? So 3 goes here and goes this way, sorry. And then 3.5 is going to go here. And then it starts looking so much the same. 4 goes here. And 4.5 goes here. So basically that's it. You're going to get a more accurate area when you approximate it. And we're going to do the same thing, but this time we're going from 1 to 4.5. And we're going to be multiplying by 1/2 because our intervals are going by 1/2. So you have to take that into account when you're doing the area of a rectangle. Because remember, the area of a rectangle is length times width. So now our width is 1/2. So basically we're doing f of 1 times 1/2 plus f of 3/2 times 1/2 plus f of 2 times 1/2 plus f of 5/2 times 1/2 plus f of 3 times 1/2 plus f of 7/2 times 1/2 plus f of 4 times 1/2 plus f of 9/2 times 1/2. Now when I evaluate this, I'm going to go ahead and pull out the 1/2 first and then just evaluate these. So you're going to get 1 plus 2/3 plus 1/2 plus 2/5 plus 1/3 plus 2/7 plus 1/4 plus 1/9, or 2/9 actually. 2/9. Now, multiplying all this through, you can use a calculator. You're going to get 1/2 plus 1/3 plus 1/4 plus 1/5 plus 1/6 plus 1/7 plus 1/8 plus 1/9. And this gives you 4,609 divided by 2,520. And this is going to be approximately 1.829 as your area. So this is actually a more accurate area than what we did before. Now we're going to use the definite integral and evaluate it. So to write the integral, you write the integral sign, looks like that. You're going 1 to 5. This is your integrand. You write 1 divided by x and then write dx. We're going to take the antiderivative of this. If you haven't done it yet, then you need to stop. But our class has done this, so we're going to keep practicing. And our antiderivative is going to be our f. So I'm going to rewrite this as x. Let's go ahead and rewrite this as 1 to 5 and x to the -1 to the dx. So this is going to be, if you add 1, we're going to get, this is going to be 1 to 5 x which is just going to be basically ln of x when you do the derivative for that, and you're evaluating that from 1 to 5. So this is going to be ln of 5 minus ln of 1. Ln of 1 is just 0, so we just have ln of 5. And that's your final answer. Thank you. Have a nice day. Bye-bye.